Let me check on you everything is fine or not. Then I will be started the lecture. I think visibility is not clear. Started the lecture. The voice issue. So I hope all is clear. Everything is fine out. Please confirm me. Voice issue. So I hope all is clear. Okay. Everything is fine out. Please confirm me. Voice issue. Okay. Okay. So welcome students. My name is Divyansu Srivastav, and today I will teach you some topic which is related to basic property of complex number. So we follow one book which names as James Ward Brown and Rule V. Churchill. Okay. So in the sequence we study about lot of things so helpful for your in future type or in future knowledge. So today in this chapter we survey the algebraic and geometric structure of complex number system. So we assume various corresponding properties of real number to be known. So in previous classes we studied some basics and in basic property four or five rule for I think six rule five rule for know about the properties of complex basic algebraic properties. So in next class we study about module. So module is nothing but it is the number of complex number. So root which is basically used in module. Moduli it means, and I will teach you some more which is related to this topic, and I it's remain today and more properties and more topic to next topic. Okay. So in this topic we starting you understand my long language. So some property. So in basic algebraic properties we now previous classes we study about some properties. Okay. In the sequence of properties we about some law, then associative law, okay, and next one is additive identity, previous classes. So in today class, we study about some more properties which is related to this section. Okay. So in this section, we study about some more properties like this, and I hope you make clear notes for this. So in this section, into such property accepted because this apply to real number. Okay, and the section without serious description, we begin to observe that some existence and multiple enables us to show the if product is okay, then so it at least one of the factors, and I hope you understand in previous classes. I think all is Z1, Z2, which gives you 0. Okay, so hopefully, and Z1 which is not equal to 0. In previous classes, I completed this, and we take some inverse part, it gives you 1. It means Z2 inverse, I think it gives you 1, because when we take Z1 upon Z2, and here I hope the numbering will be changed. I think 1 here written here. So Z1 upon Z1 which is equal to 1. So previous lecture we complete this. One more topic, inverse, yeah, I have. So in this type of Z1 in Z2 inverse, I think it written as like this for better clearance. So Z1 upon Z2 written like, and one more expression for Z1 upon Z2, which is hopefully I think it written as like this: x1 y1 in bracket x2 upon x2 square y2 square. Okay, and minus y2 upon x2 square plus y2 square. So these are some using for the expression for z1 is equal to x1 and comma y1 to comma 2. Here 0. I think the property nicely for you. So z1 plus z2 to z1 z3 and written like this. So when z1 into z2 in plus z3 into z2 inverse. So you write like this: z1 upon me plus z2 upon z3. So these are some motivation for some equation to solve a problem. Okay, I think okay, I think it's written like this, and take two. So I think let me change in other way. Okay, so take a okay, take here Z2 and third one is Z3. Now it is true for you, and write Z3 as an inverse. Hopefully in junior classes you know about the direct composition for this with Z1 upon Z3 and Z2 upon Z. Okay, so come to one term which is also related to this. So for example, to know about some method to know about some expected properties are involving some like quotients or follow the some relation. So take a one example for this. I written like this: 4 plus iota upon 2 minus 3 iota. So take a by rationalization process, iota right here, 3 iota multiply 2 plus 3 iota. It is same for numerator and denominator multiply together with add. It gives you some when you uh, it gives you some formula like using a minus b square. So it gives for minus 9 iota square, and I think add for this gives you uh, 13. In numerator, when you multiply together, uh, it plus 14 iota, which is equal to. So in you write 5 plus 14 iota upon 13. So after previous property is 5 by 13 plus 14 upon 30 iota. Okay. So involving to find the quotient that are follows for. So basically you 1 upon z2 is written like that, okay, and to 0. So which equation thing that's us to solve like one more properties, which is z1 upon z2, which is written here. Put check z and write z2 as 2, and it gives you inverse. Okay, and z2 which is not equal to 0. So these properties, and finally we got some binomial expansion for this. When you use binomial expansion, so clearly binomial formula, real number remains valid with complex number. Is if z any non-zero complex number, then is z plus z2 up to power, which is summation from equal to 0 to n. Okay, and like n and k type. Here is a combination for this, and that one like z1 to the power k, and then apply together z2 n power n minus. So n equal to 1 and something puts 1 to 3, and where n upon k to n factorial factorial and n minus k basically uh, written like this: nc upon uh, and in minus r factorial type are the basic formula used in here, and inputs like a number from 0 to up to n. So these are the uh, here it that factorial which is equal to 1. So this proof, okay. So basically these are binomial formula for any complex number. So any complex number for a real number which is valid with complex number. Okay. So hopefully you understand this. Now come to the next point, which is our vectors and moduли. So in last class, or you in a study about some. Now my next point is vectors and module. So now vectors and so these are only using vectors. In previous classes, you used mod x, which gives you x when x greater than equal to 0, and x, which is x less than 0. So minus x. Okay. So in previous uh, class 12th, you also study about the uh, basic operations using mod. So how to draw a graph for this? You draw a graph like this. Take us of this type of graph are coming, put type in module. Uh, you must start number change into complex is only a real part type. So in module, the module or absolute value for z to x plus iota y is written here. Module, the modulus. I think the best Protestant better. I use a modulus. Okay, modulus or absolute value of x plus iota y. Okay, so when you take for z, uh, it gives you some input like this. Uh, it's square root of x square. So geometrically, the z is the distance x comma y to the origin. Mod z is the distance from the point comma y to the. Now use here for this. So properties are mod z square, which is equal to real part of z square, okay, plus imaginary part of z square. Now I go to the next slide. So the real part of z, which is less or equal to modulus of real part of z, less or equal to and for imaginary part, it is a less or equal to a imaginary part of z, and then write mod z. Okay. So imaginary part is less than imaginary mod of imaginary part of z, and imaginary part of which is less than less or equal to mod of z. So mod of z is greater or equal to something like this. So you write for real part, use this type of notation. Okay. So use here and in triangular inequality we known like this. Take some mod for z1 and z2, which is greater or equal to mod of Z1 plus mod of Z2. Okay, and another when we take is for two numbers, so greater for Z1 and Z2 equal to mod Z1 plus Z2. Okay, but when you take a difference for this, it gives greater equal to Z1 minus Z2. So the distance between Z and Z2, and then Z1 minus Z2 comes. So or kill of radius are centered at Z0. It comes like this: Z minus, sorry, I will write it in above. So Z0 is mapping Z minus Z0 equal to like this. Okay. So these are the basic vectors and model. Now I am going to draw going to analyze the geometrical portion. So take a one. I use number for a non-natural associate, and for non-zero complex number take a x plus iota y. Okay, with some line segment or vector origin point like this x comma y, and replace z complex plane. Okay, so now I'm going to in a complex plane. So I will take this type of graph for this, because when you number, uh, it gives you some like this. When you take some z is equal to iota y. So and another one is minus 2 plus iota. Okay, are displayed graphically for both point of and radius vector. So origin is our 0, and for this you write me as like this x comma y, and these are our imaginary part. Put it here as y, and real part put it here as x. So in this direction gives you minus 2 plus iota, and these are the graph for z is equal to x plus iota y, and point like this 2 comma 1. For this coordinate we use as a minus 2 comma 1. When you solve this coordinate is gives you x and y. So these are our imaginary part, and these are our real part. So let's assume some corresponding point for take a one z1 comma x1 plus x2 and take y1 plus y2. So these are the vector for coordinates for its component. Hence z1 and z2 may be our take. I will show you vertically. So maybe the point you take a z1 plus z2, it gives you x1 plus x2 plus I y1 plus y. Now in some graph for this. So take some points like this. Take x1 plus x2 plus y2. Okay. Now I'm going to draw this graph. Is x and our imaginary part is y. Here use origin and these are using for a distance formula and it gives like this type of graph are coming. So and here the point is okay. So content part for this is Z1 and Z2. These are two vectors Z2 and here is written as Z1. So these are two vector part is Z1 plus Z2 and some imaginary part which is Z2. So, so the product of two complex number these are the resultant vector. So by using a sum distance formula to find the get a your answer. So in although the product of two complex numbers Z1 and Z2 it's like a number which is vectors lies in same plane as vector for Z1 and Z2. So eventually the product is neither a scalar nor the vector product used in ordinary vector analysis. So in previous lecture, I will discuss some to solve it. So in this, use a module or absolute value of z and take their modulus. It's square plus y square. Actually, I will represent this. Symmetrically. I was represent. Okay. Take one more example. No better to what I am discussed to you. So take one more example for this. Now, perfect to be use next slide. Okay, better experience to you. Now example for this. Since the example is written like this, take a mod of 3 plus 2 iota type entry. It gives you under root 13 and one more vector is 1 plus 4 iota and it's you it's given under 13. We know that. Now go to the solution. These points are closer to origin. Okay, so the distance between 2 points x1 and y. Okay, now part the 2 point x1 and y1 and more is x2. Okay, h of z1 modulus of 2. This clear. Since take one figure for this. Okay, now I am going to take a point which is joint as a point to the and I think a graph draw for this. I'm using a some easiest method for this. Two vector. Okay, two vector z2 part and take one another vector which is and now the difference in imaginary like this. Is to draw a imaginary for in between these two rays. It's like this. Okay. So I think better to see you in a better to we saw you in a where are you? These are graph. Okay. Hopefully you understand this. Yeah. I'm use this figure. Okay. Explain in this type also. Okay. So you see here some resultant part take a two vector. One where is our Z2 and here is our Z1. So when you take here is our coordinate X and Y and here is X1 and X2, here is X2 and X2. When you take a difference for this, it gives you Z2 and these are some negative part for Z2 minus 2 and here is their difference part is Z1 minus Z2. So better we know about Z1 plus Z2 which is less or equal to 1 plus Z2 and another inequality Z1 minus Z2 which is greater or equal to Z1 plus minus sorry Z1 minus Z2. Okay, so this equality by the help of these two inequality we find difference. Okay, so I hope you understand this. So here figure for this. Now I think here is some more example which have different. So here take a vectors. Here is one is retail 18 and another one for iota. So these are the closer to origin when you put a number some nearest part to origin. And Z1 is which is written as like this Z1 equals x plus iota by 1 and for Z2 and the difference are forming figure and when you length of this factor and their radius vector is Z1 minus Z2 one can interpret it Z1 minus directly line segment joined to x2 comma y2 and another point is y1 comma y2 and it gives you for difference take their difference. So these are the hopefully you want. Okay, here I take some quad modulus you square these two. Okay, basic representation for this problem and now the number is corresponding to the circle and Z0 satisfy the Z1 minus Z2 equal to R. So convert circle which is equal to the standard equation comes for the circle part. So must be learned Z1 minus Z2 which is equal to what ZR and how to find this you may go to the problem. Now come to the next example which is also and here we more is to find the problem. Okay, so you understand this. Take a one more the equation Z1 minus 1 plus 3 iota which is equal to 2 represent a circle whose center is Z0 equal to 1 minus 3 and radius is R is equal to 2 So follow the first definition. What the definition say about? This definition say about when you take a, it gives you the must square part of real part and imaginary part, and hopefully you under root real part of z plus imaginary part of z ka square. Okay, so think you better to be understand like this. Okay, here we write for real, okay, and here for write for the imaginary z. So these are turn now to the triangular inequality. So provide some upper bound to model and some two complex number one and Z2, it gives you some triangular inequality type like this. So these are the triangular inequalities and upper bound modulus. So it comes when you take a Z1 plus Z2 less or equal to Z1 plus Z2 modulus function. Okay. So these are the geometrical when you take a some triangular inequality in fact of like this Z1 plus Z2, and here it comes like this. Okay. So hopefully you understand this. So I think the derivability like this, it comes for Z1 and Z2 which is equal to the derive. This is the derive inequality for this. Okay, for equation 5. So you may be right like this. And now which means that Z1 plus Z2 is greater or equal to Z1 minus Z2. So these two inequality can interchange the Z1 and Z2 inequality in 6. So better to be the desired result for this. So because minus Z2 when you put a number in modulus function is a positive value. When you use minus in modulus 1 is minus Z2 1 Q replace that. The inequality 4 and 5 will be summarized in more particular useful form. So here is some particular useful form for this. You may be apply for both Z1 plus minus Z2 which is greater or less Z1 plus Z2. And when you use a subtract form, it comes like this. So maybe correct for this. Okay. Hopefully you understand. The come to the next example. Here is some more example. The point is its circle. One about the origin. So Z1 minus Z2, which the radius part is a unit set take here is a Z minus 2 because the okay. So modulus when you put here 1 it comes like 3. So these are the better to be here is the written here. So use a maybe use a triangular inequality like or a finite or infinite number are involving here and their sums and are using. So better to use here the notation for n is equal to 1 and inequality line and just inequality 4 more equality 9 assume that n is equal to m. So take here the n is equal to m plus 1 since by inequality 4 it comes like this. Okay. So these are some basic exercises. Now next part is complex conjugates. What is complex conjugate? Hopefully it may be better to be known uh, in a PowerPoint version. Okay. So I will teach you what topic. I am going to teach you some complex conjugate. So what is complex conjugate? These are point 5. 5 topic is our complex conjugate. Conjugates. The complex conjugates is only the conjugates of complex number. These are complex conjugates for of a complex number. When z is equal to x plus iota y, their conjugate path is nothing but x minus iota. So for conjugate, which is the reflection of real axis for. So these are the reflection like this when you take x is equal to minus y, and reflection part point का z double bar, it comes z only, and the modulus part of z, which is also equal to z for all z. Okay, so here uh, I am going to draw one more figure which is used for the this conjugates. So take more figure. Here I am write a z, their conjugate. Okay, now join these 2 points. Here is the coordinates is x comma y, and here the coordinate is x y. Okay, so these are coordinates. So just imagine conjugate part is its part. Sorry, its negative part. So I think you maybe understand the real portion using and imaginary part. Okay. Now our next aims to discuss what is this. If z1, which is x1 plus iota y1, and z2, which is 2 plus iota y2, it is nothing but their take a z1 is equal to use x1 plus iota y1. Some take their, so it gives you z1 minus z2 type. Okay, so now put the number of using where the notation z1 equal to x1 plus iota y1, and using a z2 equal to x2 plus iota y2. Okay, so we write like this: iota y1 plus y2. Okay, when you write like this, x minus iota y1 plus 2 minus iota y2. So the conjugate of sum of the, these are the sum of the conjugate. Okay, so what the thoughts comes in your mind? I think I am proceed on their multiplication part. Okay, so in multiplication part, take their conjugates are also distributed here. So when you take a z1 equal to z2, their conjugate is also z1 into z2. Okay, these are the basic product part, and they are the sum of the conjugates. So the sum of z plus z bar, what comes? So now my next you plus z bar which is equal to x minus iota y. Okay, so their addition x plus iota y, x minus iota y. Okay, cut the positive negative part, and it comes like 2. Okay, so when you take their difference, so the when you take their difference, x minus, I think plus part minus I, only x part is cut, and remain part is 2 iota is coming. Okay. So real part of Z which is equal to like this Z plus an imaginary part which is equal to like this Z minus Z minus Z conjugate upon 2. Basic representation they are using a complex conjugate and identity by using a modulus or when you product. So when you multiply these two concepts to the whole square, you and the complex conjugate to solve one more problem. Now I am going to show you a more exponential form. Okay, the algebraic properties. Now here complex conjugate. Okay, these are short triangle inequality, modulus absolute. Here the complex conjugate. X conjugate one more the property are written in static manner. Next part is our exponential form. Is in form it is nothing but is Euler formula e to the power I cos theta plus I sin theta. But in complex part you represent like this z r e to the power I theta. Here z is y, so z is equal to r. Okay, in bracket cos theta plus I sin theta. This is a Euler formula. So in next lecture we study about some more knowledge about some exponential part polar form. Okay, and the Morpher's form fruit of unity or NF fruits or you may be say that basic properties and basic complex number. Okay, you understand this lecture. We study about some more information which is used in this lecture. So I think the class is in now. Let me check on YouTube what's going on. When the class is in now. Okay, no. Okay, so thanks for watching this lecture. And next study about some more. Okay, I'm going to end the class. Okay.